In this lesson, we're going to talk about the 5 exponent laws. The first law says that when multiplying powers with like bases, you keep the base the same and add the exponents. So in other words, a to the m times a to the n is a to the m plus n. An example of that would be 2 to the 3 times 2 to the 4. The answer to that would be 2 to the 7, because 7 equals 3 plus 4. We leave the base the same, and we add the exponents. Well, what if we have a to the m divided by a to the n, dividing powers with like bases? In that case, we subtract the exponents. So 2 to the 7 divided by 2 to the 4 would be 2 to the 3. And a third one is if we have a power raised to a new exponent, so for instance a to the m raised to the exponent m, then we have that equaling a to the mn. So for instance, if we have 2 to the 3 raised to the exponent 5, we multiply the 3 and 5 and we get 15. Another exponent rule says that a to the 0 is equal to 1 so long as a does not equal 0. Specifically what that means is 0 to the 0 is undefined. So we're not talking about 0 exponents if the base is also 0. But if the base is anything other than 0, then that value raised to the exponent 0 will equal 1. So for an example, 5 to the 0 equals 1, negative 6 quantity to the 0 equals 1, 3/4 to the 0 equals 1. And another exponent law says that a to the exponent negative n is equal to 1 over a to the exponent positive n, or in other words, 1 over a to the n. An example of that would be that 3 to the negative 4 is equal to 1 over 3 quantity to the exponent 4. Notice how with that negative exponent, what we did is we got the reciprocal of the base, so the reciprocal of 3 is 1/3, and then we kept the magnitude of the exponent, but we made it positive, so 1/3 to the exponent 4. Now 1/3 to the exponent 4 is like saying 1 to the exponent 4 over 3 to the exponent 4, which is like saying 1 over 3 to the 4, which is actually 1 over 81. And finally, if we had 2/5 to the exponent negative 4, that would be like we can determine the reciprocal of the base. So the reciprocal of 2/5 is 5/2, and we make the exponent positive. So instead of negative 4, it becomes positive 4. 5/2 to the exponent 4 would be 5 to the 4 over 2 to the 4, which would equal 625 over 16. Okay, now let's talk about rational exponents. Rational exponent 1 over n represents the nth root of the base. So for example, if I ask you the value of 125 to the exponent 1/3, that's like saying to you the third root of 125. The third root of 125 is 5 because 5 times 5 times 5 is 125. So if I'm asking you for the third root of something, I'm saying what number multiplies itself 3 times, for instance 5 times 5 times 5, to give you the base. So again, the third root of 125 is 5 because if I multiply 5 3 times, I get 125. Another way of looking at that same situation would be the following. Suppose I wanted to know the value of 125 to the 1/3. Perhaps I could just let that value equal x, and let's solve for x. So x is 125 to the 1/3. I can raise the left side to the exponent 3 and raise the right side to the exponent 3. So x to the 3 equals 125 to the 3rd raised to the exponent 3. So that means x to the 3rd is equal to 125 to the exponent 1/3 times 3. So 1/3 times 3, as we just saw on the previous page, would be 1. So we have x cubed equals 125 to the exponent 1. Well, if x cubed equals 125, then x obviously equals 5. So we said if x is 125 to the 1/3, x is equal to 5. Okay? That's another way of looking at it. So, in other words, 125 to the 1/3 is 5. Okay, so let's do a few examples here. If I ask you for 32 to the 1/5, the answer would be 2, because 2 multiplied 5 times, 2 times 2 times 2 times 2 times 2 would be 32. If I ask you for the fifth root of 32, that would also be 2, because 2 times 2 times 2 times 2 times 2 is 32. So we see 32 to the 1/5 is the same as the fifth root of 32, written that way. Now, if I ask you for negative 32 to the 1/5, if that negative 32 is in a bracket, then I'm saying to you, what number can multiply itself 5 times and give you a negative 32 value? The answer is negative 2, because negative 2 times negative 2 times negative 2 times negative 2 times negative 2 is negative 32. How about if we ask for negative 16 quantity to the 1/4? That doesn't exist, because the base of the exponent 1/4 is negative 16. Well, you can't multiply a number 4 times and come up with a negative value. So this number does not exist. Negative 16 quantity to the 1/4 does not exist. But that's different than saying negative 16 to the 1/4. That looks a little weird, but in this case, the negative 16 is the base of the exponent. But in this case, the base of the exponent is just 16. In other words, negative 16 to the 1/4, like I've written it here, not in the bracket, is like saying negative, and then the base of the exponent is 16 raised to the exponent 1/4. Now, we know that the value of 16 raised to the 1/4 is 2, because 2 times 2 times 2 times 2 is 16. So 16 to the 1/4 is 2. So that means negative quantity 16 to the 1/4 is negative 2. In other words, just put a negative sign in front of each of these, and you get negative 16 to the 1/4 is negative 2. So the moral of the story is if you have the negative symbol in a bracket, then that's included in the base of the exponent. But if it's not, then that's not included in the base of the exponent. Now, we're going to have rational exponents in which the numerator is not 1. So we've seen how to evaluate a power with a rational exponent when the numerator is 1. We just did that on the previous page. When the numerator is not 1, what we do is we make it 1 and then move the numerator to the outside of a bracket as follows. So let's take an example. 32 to the exponent 3/5. What we do is we make it 32 to the exponent 1/5 and move the 3 outside. Because as we saw on the first page of this note, if I was asked to evaluate this, I would multiply the 1/5 and the 3, and I would get 3/5. Well, in this case, I'm breaking them apart. I focus on just the denominator, so I just do 32 to the 1/5, and then I put that to the exponent 3. Well, 32 to the 1/5 is 2, because the fifth root of 32 is 2, because 2 times 2 times 2 times 2 times 2 is 32. So this bracket is a 2, raise it to the exponent 3, and I've got an 8 as my answer. So in other words, like it says here, when the numerator is not 1, make it 1, and then move the numerator outside of a bracket. And that's what we just did. Okay, another question would be if we had 4 to the exponent 5/2. Well, that would be like saying 4 to the 1/2 quantity to the 5. Well, the second root of 4 is 2, and that's the second root is like saying the square root. The second root of 4 is 2, because 2 times 2 is 4. And then I take this and I raise it to the exponent 5, and 2 to the 5 is 32. What if I have 100 to the exponent negative 3/2? Well, like we said, if you have a fractional exponent, make the numerator a 1 and move make the numerator a 1 and then move the original numerator outside of the bracket. So I have 100 to the 1/2 raised to the exponent negative 3. Well, 100 to the 1/2 is the same as 10. So I've got 10 to the exponent negative 3. So what I need to do now is determine the reciprocal of the base, which is 1/10, and make the exponent positive. 1/10 to the exponent 3. That's 1/10 times 1/10 times 1/10. So the numerator is 1 times 1 times 1, which is 1. The denominator is 10 times 10 times 10, which is 1,000. And another question would be 125 over 27 quantity to the 2/3. Well, what I want to do here is, like we said, instead of 2/3, make it 1/3 and then raise to the exponent 2. So I've got 125 over 27 to the 1/3 to the exponent 2. When this happens, when you have a quantity raised to the 1/3, What you want is the third root of both the numerator and the denominator. So 125 over 27 quantity to the 1/3 is like saying 125 to the 1/3 over 27 to the 1/3. And we still have that squared here, but we'll deal with that later. Well, 125 to the 1/3 is 5, because 5 times 5 times 5 is 125. 27 to the 1/3 is 3, because 3 times 3 times 3 is 27. So I have 5 over 3, and it's still being squared. Well, that's like saying 5 times 5 over 3 times 3, which is 25 over 9. So 125 over 27 to the 2/3 is equal to 25 over 9. Sometimes we have decimal exponents. So what do we do when we have a decimal exponent? We simply convert it to fraction and we put it in lowest terms, and then we evaluate as we've just seen how to do. So for example, 16 to the exponent 1.75. Well, we can move that exponent over 2 spots, and then that decimal over 2 spots, and then that would mean we have 175, but we'd have to divide by 100. So 1.75 is the same as 175 over 100. But we have to reduce this exponent. So 175 over 100 is the same as 7 over 4. So we have 16 to the exponent 7 over 4. Well, that's like saying 16 to the 1/4 to the exponent 7. 16 to the 1/4 is 2. We've got 2 to the exponent 7, and that is equal to 128. And finally, every once in a while, you'll get a question where you're asked to evaluate a number of things and perform operations on them. And you just want to make sure that you don't try to apply laws that don't apply in that case. We're subtracting these powers, so there's no law of exponents that's going to help us bring them together in any way. So we have to evaluate each power separately. 4 to the 3/2 is the same as 4 to the 1/2 quantity cubed. 4 to the 1/2 is 2, so it's the same as 2 cubed, which is the same as 8. So 4 to the 3/2 is the same as 8. Now I can look at the third root of 27 raised to the exponent -2. The third root of 27 is 3. If I raise that to the exponent -2, I have 3 to the -2. Well, that's like saying 1 over 3 to the +2. 1 over 3 to the +2 is 1/9. So this first term is equal to 8. This last term is equal to 1/9. Now in between, I've got 16 to the -1.5. That's like saying 16 to the -15 over 10, and 15 over 10 simplifies to 3 over 2. So 16 to the -1.5 is 16 to the -3 over 2. Well, that's the same as 16 to the 1 over 2 to the exponent -3. 16 to the 1 over 2 is equal to 4. The second root of 16 is 4, and then I raise that to the exponent -3. And that's like saying 1 over 4 to the +3. And 1 over 4 to the +3 is 1 over 64. So basically what I've got is 8 minus 1 over 64 plus 1 over 9. And so I can re-express 8 as 8 over 1. 8 over 1 minus 1 over 64 plus 1 over 9. And then I just do some good old-fashioned fraction work. I have to determine my lowest common denominator, which in this case is 576. So this first fraction becomes 4,608 over 576. This next one becomes 9 over 576, and this last one becomes 64 over 576. And when I leave that new denominator alone and I subtract and then add across the numerators, I get a numerator of 4,663. So the final answer is 4,663 over 576.